Start.
Okay, hello everyone. It's me, Ram Saransa from Mithila boarding school, the compulsory mathematics teacher. Today, I'm going to start the combined classes for class 8, 9 and 10. This is first day and I'm going to start topic set chapter. Before starting the chapter, we'll understand the meaning of set. Generally, we people understand set as a collection of objects, but we should not only term the collection of objects as set, because for being set there must be the well-defined objects. There must be the well-defined objects. For example, I have written like for example, you can see here a collection of well-defined distinct objects is termed as set, and the examples I have given here: the collection of fruits, a collection of natural numbers. These examples are the sets. But if we consider the collection of sour fruits, or you can consider the examples of sweet fruits, these examples are not termed as sets, because sour fruits, like for example mango, some people taste mango as sweet, some people taste mango as sour. So this mango is either sour or sweet. We cannot determine, we cannot distinguish. That's why a collection of sour, a collection of sweet fruits, these are not termed as sets. That's why, to be clear, you should understand set as well-defined distinct objects. The objects which are determined, which are considered by everyone, those collection is only known as set. Now, how we are going to denote or notate the set? Set is denoted with the capital letters. That's why whenever we are going to denote the set, we will denote it with capital letters. Like for example, I have given here example set A. Set A is equals to A, E, I, O, U. Here capital letter A, capital letter B denotes set, and here the small letters A, E, I, O, U, A, B, C, D, E are known as the elements of the sets. Now we will understand the types of sets. There are so many types of sets. We will consider some of them here. First, we are going to study is empty set, which is also known as null set, or we can say it void set. An empty set is the set with no elements. A set having no elements is known as empty set. Like for example, if in your school there is no lady principal, and you are going to say that the collection of principal or the collection of teachers, for example, in your school there are not, or we can take another example. Like for example, in a girls school, if we consider a collection of boys student, that set will be an empty set. That set will be an empty set because in girls school there can be no boys. Another example you can take a collection of numbers, a collection of even numbers between 2 and 4. Between 2 and 4 there is only one number, that is 3, and that is odd. That's why a collection of even number between 2 and 4 is also an empty set. Now the next set is singleton set or the unit set. Singleton set or unit set is a set having only one element. A set which have only one element is known as singleton set. For example, a collection of natural number, a collection of natural number between 4 and 5. Between 4 and 6. Between 4 and 6 we can get only one natural number, that is 5. That's why that is known as singleton set. Now finite set, a set having countable number of elements. If we consider any set where we can count the number of elements, is known as finite set. And the set in which we cannot count the number of elements, how many elements are present in that set, is known as infinite set. For example, a set of natural numbers up to 100 or between 10 and 20, these can be counted, how many elements are there. But if we consider the set of numbers, a set of numbers only, so can we count how many numbers are there? We cannot. That's why a set of numbers or set of natural numbers, a set of even numbers, if we say like this, that will be infinite set. Now overlapping set, the fifth type of set is overlapping set. Overlapping set, if we have to understand, we have to understand two or more sets. If there are two or more sets, then the relation between those two sets is known as overlapping sets. And when they are said to be overlapping sets if they have at least one element in common. If two or more sets, not only two or more sets also, if they have at least one element in common. At least one means what? There can be more than one elements in common as well. So if set A is equals to A, E, I, O, U, set B is equals to A, B, C, D, E, here A, E, here also A and E. In set A, in set B, in both sets there are two elements common, that is A and E. That's why they are overlapping sets. But if two sets, two or more sets, they have no elements in common. No elements in common, they are known as disjoint sets. Like for example, A, B, C, D, E. In set A, in set B, X, Y, Z. There are no elements in common. That's why here set A and set B are disjoint sets.
Pause करिए कि ना
Pause continue.
pause करिए सर
नहीं पॉज है
pause अच्छा नहीं
Pause.
माफी हाँ
Yeah. The seventh type of set or operations in set is difference of sets. The difference of two sets is the set which consists of elements of only first set excluding the elements of second set. That means what? If we have two sets A B, C, D, E, B, A, E, I, O, U. Here, if we subtract set B from set A, we will subtract all the common elements of set A and set B and we'll put the elements of A only. Like here you see A and E are the common elements in A and B. We are excluding these common elements and writing the elements of set A only, that is B, C, D. That's why this is known as A minus B, or which is also known as only A set. Here, second example, B minus A. If we subtract set A from set B, that means we will subtract all the common elements of set A and set B, excluding all the elements of set A. Like for example, here A and E are common elements. We have excluded A and E and we have written only elements of set B, that is I, O, U, I, O, U here. That's why we have understood A minus B, B minus A. So we can write how can we write the difference of sets? Now the second difference is symmetric difference. Symmetric difference means what? If we symmetric difference of sets is known as difference of union of sets and intersection of sets. If we just subtract intersection of sets from the union of sets, that is termed as symmetric difference, or we can also mean it as union of only elements of two sets. That is, if we combine set A minus B and set B minus A, that is known as symmetric difference. For example, here A is A, B, C, D, E, B is A, E, I, O, U. Union will be A, B, C, D, E, I, O, U, all elements of A and B. Intersection means A and E, only common elements of A and B. If we subtract this intersection from the union, whatever elements we will get, that is termed as the symmetric difference of sets. Now the most important topic for the mathematical calculations of the problems of set chapter is cardinality of sets. Cardinality of set means the number of elements present in the set is known as cardinality of set. In any set, whatever number of elements are present, that is termed as the cardinality of set and denoted as n bracket that set. N bracket set A means the cardinal number of set A. N bracket B means the cardinal number of set B. Here in set A, B, C, D, E, there are 5 elements. That's why the cardinality of set A is 5. Set B, there are no elements. There is no elements. That's why the cardinality of B is 0. Set C is equals to 1, 2, 3, 4, 5, dot, dot, dot. That means it has infinite elements. That's why the cardinality is infinite. So now we are going to remember or study some of the formula that we are going to use on set chapter for two sets. The problem based on two sets. Here the first formula cardinality of A union B. For the cardinality of A union B, we will add set A, cardinality of set A, cardinality of set B, and subtract NA minus A intersection B. So the NA plus NB minus NA minus A intersection B, or another formula we can use is N only A plus N only B plus NA intersection B. This formula we are going to use when the only sets are given. NA plus NB minus NA intersection B will be used when set A, set B, the cardinality of set A and set B are given, and if for the disjoint sets, for the calculation of two sets which are disjoint, we are going to add only the cardinality of set A and set B. If the complement is given, then we will subtract the complement of A union B from the universal from the universal set to get A union B. Now NA intersection B, we have NA plus NB minus NA union B. If you have remembered the formula of union, you can also use the formula of intersection by just replacing A union B in place of A intersection B and A intersection B in place of A union B. To find the only sets, we have to subtract the intersection part. Like for example, N only A. For finding N only A, we will subtract N A intersection B from set A. To find the only B, we will subtract A intersection B from set B. Now to find the complement, we have to subtract. To find the complement of any given set, we have to subtract the given or the particular set from the universal set. For example, N A union B complement means N universal minus N union B. To find the complement of N A complement, we have to subtract N A means the set A from universal set A. Let's see, for example, we have NA is equals to 65, NB is equals to 50, NA intersection B is equals to 15. Then here, if we have to find N only A, then we will write here NA minus NA intersection B. Here we have NA is equals to 65, NA intersection B we have here 15, so 65 minus 15 is 50. That means N only A will be 50. That will be your answer. Similarly, if we are going to find N only B, then that will be NB minus NA intersection B. What is the number of NB? We have here 50. So 50 minus NA intersection B is 15. 50 minus 15, 35. That will be your N only B. In this way, we can find the only sets. If we have to find NA union B, but we have formula NA plus NB minus NA intersection B. So NA is 65, NB is 50, and intersection is minus 15. So by adding this all, we will get here 100. That will be our union. If we are given only A, only B, in that case, if we have to find A union B, we will use here N only A plus N only B plus N A intersection B. N only A is 50, N only B is 35, and A intersection B is 15. So in this way also we will get 100.